Okay, so on this very first page, what I'm trying to get you used to with what I am offering, let me move over to the doc cam. With these pictures that I'm offering, is I'm trying to get you to get comfortable, because a lot of this class you're going to spend drawing a right triangle in a particular quadrant. What we're going to do in trig is we're going to take a circle and we're going to paste it to the XY axis. We're going to superimpose them, and what we're going to do is inside the circle, we're going to have a spinner that spins around the edge of the circle, and in some way, to get you used to it today, I will be giving you a hint as to where to stop. So you're going to spin, and maybe you'll stop in quadrant 1, maybe you'll stop in quadrant 2, and I'm going to clue you in on different ways that I am going to tell you what quadrant you're in. I'm going to verse you. Sometimes I'll say, and now everybody here knows that a circle is 360 degrees, right? So when you are in a circle, sometimes I'll have you stop, in quadrant 1, as I was saying, sometimes in quadrant 2. And I'm going to be using certain words about what is spinning and what is staying pasted to the x-axis. So that's what this terminology is about. Okay, always. When I start to spin, because what I'm going to do is spin and create a picture of a right triangle. You're going to see that I always keep this side, called the initial side, pasted to the x-axis. It's like it's taped to the x-axis. Then one of the sides, because you're starting off with 2 rays. Rays are the things that make an angle. So this is a ray and this is a ray. They come together at a point. So most of you have had geometry. I'm going to go over a lot of your geometry. So the 2 things that come together at a point are called rays. One ray is going to stay pasted to the x-axis while the other one spins. The other one's called, the spinning arm is called the terminal side. The side that stays affixed to the x-axis, that is called the initial side. So that'll be the initial side, and it will always remain pasted to the x-axis. Whereas this terminal side, this will be the side that spins, and it will spin either to quadrant 1, 2, 3, or 4. So you're going to imagine that this is right, this vertex will be right at the origin. It will be pasted to the origin. So some things will move and some things won't. Okay, now you're going to see that, and you're going to do the thing that you have to get used to. What is the difference between a positive angle, a positive rotation, and a negative angle? When I take the spinning arm, that's this terminal side right here, and I take this terminal side and I spin it in a counterclockwise fashion, as you see happening right here. This is a clockwise fashion. See how this arrow is right here, and that they're pointing which direction the spinning arm is going. So this is what we call a positive angle, because you're spinning in a counterclockwise fashion, which I wrote for you right there. Another thing about these notes, I wrote most of the stuff for you so that you can just add in whatever you want to the notes, whatever your own little comments are. Okay, so when this thing spins in this direction, you're going that way. It's just going like this, basically. It's spinning like that. That's what we call a positive angle. When it's spinning clockwise fashion, like the arm is going like this, it's spinning like this in a clockwise fashion, that's what we call a negative angle. And every problem that you start for quite a long time is going to start with you having the terminal side the terminal side spinning, and then the initial side pasted to the x-axis. You're going to spin somewhere. That spinning arm, the terminal side, is going to become the hypotenuse of a right triangle, and your entire study of trig will be based on the right triangle inside of a circle. Okay, so that's what we're going to be doing most of the time in this class. There'll be one chapter or two that lets loose of that, but really in almost the whole class, that's how we're going to start. Okay, so again, you got the same pictures here, just bigger, but now it's what I was just saying when I was talking up there, that you are going to keep one side pasted, other side spinning. Again, when you go in a counterclockwise fashion, the angle is positive. Now look at this angle right here. It is at the center of a circle. You can superimpose a circle around here, but it's at the center. The vertex is right at the center of this XY axis. So this is called a central angle because the vertex is at the center of this XY coordinate system. Now, I want you to take note of the fact that right now they are calling this theta, and later I'm going to start talking about not only theta, but theta prime. That's going to be super important. The theta prime will have like a little mark on it that looks like an accent mark. It'll be a theta, but with a little accent mark. It'll be called the reference angle, and it's going to be the whole key to you getting the answer. So I'm going to stress that a lot. So there'll be a theta. Soon I'll be talking about theta prime, or what we call the reference angle. Again, you can either spin this way or you can spin the other way. This is a negative. When you spin this way, it's a negative angle. All right, let's practice. Come to this next page. Okay, now this I already spoke about verbally as well. I was telling you that when you start spinning the terminal side, that's this guy right here. This is the terminal side. Remember, the initial side stays fixed along the x-axis. So there's your terminal side. It has spun into quadrant 2. This side that stays pasted to the x-axis is called the initial side. You'll always have that situation. Since this is going counterclockwise, this is what we call a positive angle. A positive angle, central angle. There's the angle right in there, in between the two rays. Okay, here, this stayed pasted to the x-axis. That's what you're seeing here, called the initial side, while the angle that was on top of it began, the ray that was on top of this, because they both start off pasted to each other. You start off like this. Okay, they're like this. And then one side either spins this way or it drops down that way to get either a positive angle. So both of these were initially on top of each other, and then one of the arms dropped down in a clockwise fashion, and that's what we call a negative angle. Now we'll start putting numbers on this, but just so you get the terminology. Okay, this, you're going to see me use this phrase quite a bit. Sometimes the spinning arm lands right on one of the axes, either on the x or the y axis, and in those cases you will not be able to draw a right triangle. You'll be able to draw a right triangle in every single situation except this. See, this was these were both, you had two rays that were on top of each other, but one of them took off, started spinning until it landed right there on the negative y-axis. That's what we call a quadrantal angle. This is the angle, the opening that was created in between the initial side and the terminal side. This is the terminal side. This is the initial. The initial is always the one that stays pasted to the x-axis. Okay, that's all these pictures are. Pictures of rotations. There's no problems here until you get down to this. Okay, so what are these pictures of? Things that you've probably seen before. That's what you call a full rotation, also known as a full revolution. So basically you had two arms. One kept spinning until it landed right on top of the initial side again. So that's what we call a 360-degree rotation. And it is positive because see how they're going like this with the arrow? That means one of the arms spun like that until it landed right there again. Here, this is what you call a 90-degree angle. I'm sure most of you know that. When two rays meet and the angle is 90 degrees indicated by that little square, It is considered 1/4 of a revolution because of this. 90 degrees is 1/4 of 360. So a whole revolution is 360. You can put that in there if you want to. If you're not used to the word revolution, 1/4 of 360 is what you're seeing right there. So that's your theta. Here the theta is 360. Here the theta is 90.
So on the quadrantal angle, that was a 270 revolution. The one above it.
This one right here?
No, the C on the prior section.
Oh, that one right there? That's 180.
Not the one that's on the board, the one on top of it.
Oh, okay. Let me slide it down.
The quadrantal on the one prior to the.
Yes, that is 270.
270 revolution.
Yes, that's the only one that you can tell exactly where it is because, yeah,
But
this
it
is
wouldn't say
270.
90, right?
No, it won't say 90.
It would be exactly
This is why it's 270 rather than 90 because of the way it's spun. Can you see that you've passed through 3 different quadrants all equaling 90? Therefore, 90 times 3 has to be 270. If they wanted it to be 90, see how that arrow is going like that? It will be going like that. It will be pointing like that, and then it will be negative 90. Negative 90 and positive 270 are 2 names for the exact same location. Okay, but if you want to refer to this one, just because of the way this arrow is pointing, it has to be a positive angle, and you have to take into consideration what it's passed through. 3 90-degree quadrants, 270. Okay, let's draw. Now we're going to draw pictures ourselves. You don't have to be like super accurate or anything, but try to get as accurate as you can. Now some of them, you should be hitting them right on the nail, like stuff like this. Now, even though it's not time to do so, I am going to drag in the conversation of reference angle. I'm going to put all of that in this picture. Okay, here we go. Draw a y-axis, draw an x-axis. We're going to base our pictures on that. Now, everybody knows that every single quadrant is 90 degrees, right? 90, 90, 90, 90. So if you're going to go 45, isn't that half of 90? So a fair estimate would be for you to draw a ray that's halfway in between this and this. That's all. So you'll keep one ray right here, and then you'll make the other one just like halfway. And right in there, you could put your little theta in here if you want. You can jazz it up a little bit. Write what it's equal to. Give me a nice picture. You don't have to write the word terminal and initial. I'm just pointing it out to you to be specific. Okay, now, I did mention this thing about reference angle, right? When you have an angle that's in quadrant 1, and you better label these in case you're stale on this. This is called quadrant 1. Quadrant 2, even though it has it in the pictures above, this is called quadrant 3. This is called quadrant 4. Okay, I just spun in a positive fashion. That's why you saw me call this positive 45. And I did that because they gave me a positive angle. So that also told me which way to spin. Okay, now I'm going to spin negatively. I'm going to draw a picture of a negative spin. Now, if you want to be real clear in the picture about which way you're spinning, you could go like this. See this little thing right here making up the angle? You could go like that and put an arrow to show that you rotated in a counterclockwise fashion. Okay, now let's do this one. Now, if you want to move ahead of me and draw the rest of them, you're welcome to do so. Okay, here is my arm that's going to stay fixed. I'm going this way, so you can go ahead and put that arrow there. I'm going this way, and I'm going to stop at 90 degrees. But because of the way I'm rotating, this is called negative 90 degrees. Now, this ties right into the conversation that I just had with this young man. Another name for that is positive 270. But because they told me to spin in a negative fashion, I put the little arrow like that to show that I dropped down. That's considered a negative spin. And how far did I go? 90 degrees. That's called a quadrantal angle because you're not in any one quadrant specifically. You're not in a unique quadrant. You're right here. So you can draw the other arm right here. You might want to darken in your arm so that I know you know what you're doing. Okay, now I can talk about reference angle. Okay, let's draw this. Okay, now I want you to get yourself very comfortable with the landmarks on the XY grid. So, for instance, I want you to be fully aware that that location right there is 90 degrees, that this is 180, because I will constantly be referencing these things. This is 270. This is called 360 degrees, but you could also call it 0 degrees. Every location on the circle, see what you're studying right now, these are called circular functions, meaning that you can keep spinning to that location over and over again, and every time you spin to it, you rotate around the circle, it gets a new name because you've added an extra 360. So any location on that circle can go by an infinite number of names, depending on which way you rotate and how many times you've done a full rotation. Okay, so I am going to rotate 225 degrees. Now, because you're aware of the landmarks, you know that this is 180 degrees, right? So therefore, if you're trying to get to 225, doing a little bit of subtraction on your, either on your calculator or in your head, how far beyond the 180 do I have to go? 45 degrees. Right, so you're going to go 180. You're going to keep going. You're going 45. That means you're halfway in between the 180 and 270, because remember, every quad's 90. Halfway in between here and here is an extra 45. So what you're going to do is you're going to label this whole thing until I stopped is called theta. We went 225 degrees all the way until we stopped right here. This was the arm that stayed fixed to the x-axis. Now come in here, and I want you to introduce this into your picture. This is called theta prime, also referred to as the reference angle. What was that extra little bit that you went to get to 225? 45, right? That's your reference angle. It will dictate the kind of triangle that you end up creating as you get deeper into the trig. Everything you do here, by the way, is going to be based on your knowledge of, from geometry, but this was in 10th grade, you probably took it, or maybe 9th grade, 30, 60, 90 triangles, and 45, 45. So I'm going to keep reminding you of the formulas. I'll tell you about them in a minute. Everything's going to play out to be one of those. So I'm going to make sure and get you reviewed on that. But anyway, so that is the reference angle right there. It dictates the kind of triangle that you'll be creating. Because, by the way, let's just look into the future a little bit. When you do start creating the triangles, all you're going to do is this. You're going to spin. You're going to stand on the edge of this terminal side, and you're going to travel to the closest x-axis. So if I wanted to create a triangle right here, I would just go like this. From the edge of the terminal side, I would go straight up, hitting it at 90 degrees, and that would tell me that I'm in a 45, 45, 90 triangle. You're always going to hit the x-axis at 90 degrees. You're going to see every time I create a triangle, I will hit the x-axis at 90 degrees, but because of the reference angle, you're going to automatically know the other two angles. Those two angles are going to allow you to find all the sides on the triangle, and that's how you answer the questions. So most of it will be based on that. Okay, any questions about this so far? One more picture. Let's draw a picture for the 405. Okay, now before you draw, I want you to look ahead and tell me. See if you can figure it out in your head before you draw. What quadrant are you going to land in for 405? 1. Okay, because if you're doing it in your head, aren't you thinking in your head, full revolution, 360, and then an extra, how much? 45. 360 plus 45 is 405. Now, if you didn't know that, you could just go on your calculator and you could go 405 minus 360, 45. And you could get that little extra reference angle. Here's the picture. So you have one arm that stays fixed here. You're going, shh. You don't have to draw that part if you don't want to. 360, and then you keep rotating, and you're right here. So you were going this way, and you don't have to make repeated arrows. You don't even have to draw the circle. Okay, the circle's optional. All you have to know is that You went past 90, you went past 180, you went past 270. Not that I expect you to put this in either. I would love for you to label the terminal side as theta, or you can put it right here. You can put it like right on the anywhere on the edge of the circle that we went all the way to 405. I like to put it on the edge of the terminal side. That's where I put my theta. And then I like to go in there just so I can get you ready for these triangles that you're going to be drawing and do the reference angle. The reference angle has a definition, by the way. It is the space between the terminal side and the initial side, which would be that little arc right in there, that little angle. It is always an angle that touches the x-axis and the other side of the angle touches the terminal side. So maybe you could put that. There is a definition for reference angle. One edge of the reference angle touches the terminal side, and the other edge of the angle touches the initial side. This reference angle will always be wedged in between terminal and initial and the x-axis. So that was an extra 45. Okay, so said another way, the entire angle is called theta. The little itty-bitty angle between the x-axis and the terminal side, that's called the reference angle, and it was 45. Okay, do you want to stop and ask any questions? Okay, so now we're going to start, I believe, converting. Okay, now did everybody see that on the pictures that I've been drawing? That 180 degrees, half a circle is 180 degrees. That's also called pi. So if you do want to draw that, not that you have to, but you do have to have it memorized, that this location right here is called 180, also known as 1 pi. When you go all the way to 360 and you double that, that is known as 2 pi. Now, either one of these pieces of information would be adequate to do your conversions, but I'm just going to go with the 1 pi. I mean, I could use, because you need to know an equivalency in order to convert things from pi to degrees. You can either go 180 is equal to pi or 2 pi is equal to 360. I want to keep the numbers smaller, so I'll go with this right here. I'm going to use this to convert. Okay, watch how I do it, and then you're going to try some in my math lab. We're going to start with 102. You always start with whatever they give you. Put a little converter fraction. This is called dimensional analysis, where you get one unit to go away, and you introduce the unit that you want. If you're in degrees, that means you're going to radians. By the way, whenever anything's in pi form, decimal form, that's called radians. Decimals are called radians. Okay, so maybe you want to put that in your notes. Anything in pi form or decimal form, because you know pi is a decimal, is called radians. I'm telling you this so you can understand the directions. If they're saying for you to convert the degrees to radians, that means they want you to take it to pi form. There's no need to go to decimal form. When you're in pi form, you're exact. When you go to decimal form, then you're only close to the answer because you're going to have to round it off. So if they say go to radians, go to the pi form. Don't take it all the way to a decimal unless somebody says, hey, convert to radians and round it to the hundredths place. When it says round, that's your clue that you can give a decimal answer. So here we go. We're going to go 102. Go get this. The unit that you want to go away, the degrees has to be, that unit has to appear on two different levels. The unit that you want to go into, that you want to end up in, always goes on the top. And these two things that are in the fraction have to be equivalent to each other, equal to each other. Okay, always make sure that the unit you want to get rid of appears on two different levels. You know 102 is the same thing as 102 over 1. So that means this is on the top and while this one's on the bottom. That's why they cancel. Okay, now let's get your calculator to help you out. If you don't know the graphing calculator, please get one. You can get them on eBay for very cheap. If you don't have one, do it on your phone. I don't know that your phone, I just wanted to show you how to reduce fractions. You probably know how to do this already, but those of you that don't, I'm going to show you. Okay, so just so you're seeing this and it's part of the video, I'll do it both places, but let's see. Okay, turn it on, clear it out. All right, so you're going to put in your calculator 102. This is really all you have to do. This pi is going to hang out in the answer. It'll be part of the answer. It'll be off to the side. So really all I need for you to do is to reduce this over this. I mean, if you were to write this out, this is what it would look like. You would temporarily have it written like this. 102. The degrees are gone. The pi is in the top. The 180's in the bottom. Excuse me, erase that because they canceled and went away. So instead of you giving me an answer where you have a big old 102 on the top and a 180 on the bottom, I'm just looking for you to give me a reduced answer, and I'm just telling you your calculator will do that for you. Just press in your calculator this divided by this, and instead of pressing enter, like when you wanted to figure out what 102, press math, enter, enter. So you're going to go 102 divided by 180. There it is. I'm not going to press enter. I'm going to press math. You're doing a fraction. Press enter twice. There it is, right there. The most reduced form of the answer. So all you have to do is now go write 17 over 30 with a pi at the top. And you're in exact form. You do not need to drag the pi into it. Because I know some of you are going to want to go too far. You're going to want to go 17 times pi divided by 180. But then you're doing a bunch of extra steps that are not necessary. So give the answer in its exact form. Again, I pressed in 102 divided by 180. And then I hit math right here. And I press enter twice. Okay, this is considered an exact answer. And don't let that pi drop to the bottom, because then you're giving a different answer. You can let this be off to the side, but don't let it drop down here, because then that means something else. Sorry. Okay, I'm not going to do that one. Because I just did one like it. Let's try one of these. These are easier. I think the way that you could handle this, 2 pi over 3, is that you could just go like this. If it's in, you're already in radian form, right? You're in pi form. So that means where else do you have to go but to go into degree form? It's either go to degrees or go to pi form. They're starting you off with pi form. The quickest way to get to this answer, just go stick a 180 right in there, right? Pi is equal to 180. So if you want to do the least amount of steps possible, I would just go like that. Pi is equivalent to 180. Therefore, you can replace one with the other. Divide by 3. Sorry. Put that in the calculator. Okay, here we go. Everybody got that? So 2 times 180 divided by, there was a 3 on the bottom. There you go, 120. Keep the degree symbol. Okay, here's a whole table down here at the bottom. This is just another one just like that. That's another one just like that. I mean, I'm not into memorizing tables. To me, that just loads up your head with a bunch of unnecessary stuff. Just know how to convert whatever I give you. I mean, it's simple. If I wasn't speaking, you could literally do that in 5 seconds. Less. You could, I mean, the ones that we're going to really be working with are the 30, the 45, the 60. These are common ones that we're going to work with. All right, then there are these kind of problems. I'm going to teach you how to do them by hand and also by calculator. In the end, I think you should just do these by calculator. Ones that are in degrees, minutes, and seconds. But I do want to show you how to do it by hand just in case, you run across a problem in my math lab where they force you to do it like step by step. You know how sometimes they do that. So I'm going to do it both ways, but on a test you can just do it by calculator. All right, so first one. It says, now we're going to convert again, like we just went from degrees to radians, that sort of thing. Okay, so it says, convert this to a decimal in complete degrees. Okay, you're trying to convert everything into degrees. So, do you notice that there are 3 pieces to this problem? You have in part A, the front part is in degrees, the 50. The middle portion is in minutes. That is a certain portion of the next degree. And then 21 seconds. Seconds is a portion of minutes. So these are all little itty-bitty pieces leading up to the 51st degree. It never quite made it to 51 degrees. So this is a portion of that next degree, and this is an even smaller portion of the next degree. We're going to convert it to complete degrees because that's what the question says. Convert this to decimal degrees, and then instead of having 3 symbols like you see right here, we'll just have 1. It'll be in degrees. Okay, here it is by hand, then we're going to do it by calculator. Okay, all we have to do is mess with this guy and this one, because that's already in degrees, and then we'll add it to the 50 degrees that we already have. Okay, so 6 minutes. We're going to convert, so put a little converter fraction right here. Go grab the equivalency statement. See how it says 60 minutes is 1 degree? Okay, minutes, minutes. And we're going to be going into degrees here. There are 60 minutes, so says this little equivalency, in 1 degree. Okay, get your calculator. Now we're going to go decimal style here because the directions said we could. See, to a decimal in degrees. So put that in your calculator. It's just 6. 6 times 1 is just 6. These are gone. You could cancel that out. Those are gone. So what we're getting is in degrees. So it's 6 divided by 60. Go put that in your calculator. You're in degrees with this answer. 6 divided by 60. Everybody get 0.1? So this is 0.1 degrees. Now go get the other portion of the problem. See this little 21 seconds? We have to also change that into degrees. So here's that piece of it. Okay, we're at 21 seconds. We want to get rid of seconds, go into minutes. Okay, there are 60 seconds in 1 minute. Everybody has that one memorized. Everybody knows there's 60 seconds in 1 minute. Okay, that's the symbol for seconds. 60 seconds in 1 minute. Keep going with that. At that point, you will have, let's not put it in the calculator yet. At that point, this will be gone. You're in minutes now. Go again. Okay, now do what we just did here. There are 60 minutes. See, minutes up here, minutes down here in 1 degree. Okay, now the minutes are gone. That cancels with that. Now get this in your calculator. It's 21 times 1 times 1, 21. Only symbol left is the degrees. And then we're going to have to divide by 60 2 times. Now there's 2 ways to put that in the calculator. It's up to you how you put it in. You can either know that this is 6 times 6 is 36, right? 3600 with 2 zeros on it. So if you want to just press the division sign 1 time, you could go 21 divided by 3600. That's what that number down is. If you don't want to do that, you could go 21 divided by 60, then divided by 60 again. That's another way to press it. It's up to you. I'm sorry. I'm so sick. 21 divided by, I'm going to do 160 at a time. Everybody, now why don't we hold on to about 4 decimals there, 0.0058. And we're in degrees. Okay, finish the problem. Okay, we had 50 degrees to begin with. This portion right here gave us 0.1. And this portion gave us 0.0058. Put that all together. And you get 50.1, let's see, what are we rounding to? 4 decimal places, 50.1058, that's the answer that I got. There's the 0.1, there's the 50 we started with, and the 0.0058 is in there also. Okay. Any questions about that? Okay, let's do the whole thing by calculator now. We're gonna cut out all this work and just get the answer by calculator. You're allowed to do it like that on the test. All right, so what you can do here, it's really simple. Okay, you just have to know where to get the symbols that were pasted to the 6 and the 21, and they're all under what's called second angle. You know where the second key is, right? First column all the way at the top. Okay, so here we go. We're going to press in 50. I want to paste a degree symbol to that. So go second. Here's the orange key right here. Let me slide this up so you can see it. So go second angle. In the second column, third key down. Second angle. It's the apps key. Grab that degree symbol by pressing enter, and it'll paste the symbol. Now let's do the 6. The 6 had the minute symbol. We'll do 6. Second angle again. Go down and grab that minute symbol. Enter. All under second angle. Now, I don't know if you noticed it, but there was nothing for seconds there. Seconds is the green function. So what do we have, 21 seconds? 21 seconds. You're not going to find it under second angle, but see it right here in the last column? See it right there where it says memory, the plus sign's right there? And see how it's in green? Just go hit the green button and grab that symbol. So now I'm going to go alpha, green key. Go touch the key that has the second symbol on it. Now all you have to do is press enter. See? Same answer. That we just did all that work for, that's the same answer. Okay, so now you know how to do it by calculator. Maybe you should put that in your notes. Second angle is where you get this symbol and this one. Alpha key, which is the green key, is where you get the seconds symbol. And then I just pressed enter after it. All right, next one, part B. Ugh, I just turned it off. Sorry about that. Okay, so part B, we have 21.256. And this one, you're going to convert it to degrees, minutes, and seconds. Again, these ones where you're just converting from one unit to the other with the degrees. Not the ones where you're going from pi to degrees. I want you to do those by hand like I did on the previous page. But these, you can just do them in the calculator. So they want you, this is how we just got our answer. That answer that we were just working on, and I showed you how to do it 2 different ways. We were going for this deal right here. Now they want you to take it back to what that last problem was like. Remember, it had a 50 with a degree, and then a 6 with a minute, and then a 21 with seconds. I want you to get it back in that form, and you can do it with one key. All you have to do is, first of all, you see how this is in degrees? Make sure your mode on your calculator is in degrees so that your calculator knows what you're feeding in is in degree mode. So here's the mode key. We're going to put in 21.256. Just check out your calculator first. Hey, do you see that mode key right there? Let's see, where is it? Right there. See that at the top? Check that out, press it, and then look and make sure that the word degree is highlighted. If it is not, you can just use these up-down arrows to get on top of the word you want. It'll be blinking on the word you want it to be on, and then press enter. Because you're going to see that in this class, we're going to switch back and forth from radian to degrees. But right now, we're feeding in a degree type number. It should be in degrees. Okay, so I already see that it's where I want. Let's quit out of there without changing the selections. Push second, quit. Okay, now go press in the number, and it'll already know that it's in degrees. You don't need to go to second angle and paste the degree symbol. Since the mode is in degrees, it'll assume the whole number is in degrees. So press in 21.256. Bam, it's in degrees. Now they wanted you to go into degrees, minutes, seconds. So that we're going to hit second angle, and we'll write it on our notes. Second angle. Do you see option number 4 where it says DMS? Degrees, minutes, seconds. So go down with the arrow key right here. Enter. Enter again. There you go. Okay, we took it back to the way, and I would like you to round that off. Unless it says give that in tenths. You could just go to 21 degrees, 15 minutes, 22 seconds. That's closer to 22 seconds. Okay, why don't we write what we pressed? We went this. We made sure that the mode was in degrees. So we checked that out first. Then we pressed in the number. Just like this, without the degree symbol. Then we went second, angle. We went down to option 4, DMS, and we pressed enter twice. Okay, those are the keystrokes for that particular problem. Okay, we checked this first. We pressed in the number without putting a degree symbol there. Then we went to second angle, down to option 4, enter twice. You know what? My regular MO is going to be that we're going to break from what I'm saying and go into my math lab, but I chewed up that time with talking about the syllabus, so I think I got to go straight through. I'm sorry about that. So now, you guys go home. Regardless of where I get in this section, I'm going to get pretty close to the end here. And you go do all the 6.1 homework. If you need an additional example, remember, my math lab doesn't have a view example key. And then also, don't forget, in the content folder, I have worked out all these problems for you by hand. And you're going to have the video, because I'm going to post the video right away. So I'll always make sure that even if I don't get every single problem done, I'll stay in here and finish the video because it'll maybe be like 1 or 2 problems and that whole video will be right there, okay? So you guys are going to be good. Okay, let's keep going. All right, so now what we're going to do is we're going to find what's called finding the length of an arc. Let me draw a picture of this. Okay, so let's say that you have a circle like this and you have 2 rays that were at the center of the circle, right there. This is called theta. This out here, see this the little rim of the circle right there? That's called the arc length. This is an arc. It is a portion of the circle that's cut out by the 2 rays. See, this digs into the circle right there. This digs into the circle, and it creates what's called an arc. And you're going to be finding its length. Okay, you're finding a circular length. This is the formula. R stands for radius. Radius of the circle, very self-explanatory. And this stands for the central angle. By the way, every formula that includes theta in it, the theta needs to be in pi form. You cannot do it in degree form, so you're going to have to get used to that as you're doing these formulas. Central angle theta in radian form. Okay, so let's do a couple of these. By the way, these are, for some reason, highly missed on the test. I don't know why, because they're super simple. There's only two things. You're multiplying two things. Sometimes you're going to have to solve an equation. So just write the formula down. Don't forget to put theta in pi form. Now, sometimes they'll give it to you in pi form, so you really don't have much to worry about. Okay, it is my job to get you better at your arithmetic skills so that you're not going over to your calculator every time you can't figure out how to multiply two fractions. So we'll keep practicing that. Okay, so what's the radius? 20? So it's going to be radius times theta. 20 centimeters for the radius. We're multiplying that by theta, but the central angle, theta, is already in pi form, so good for us. Okay, when you're multiplying, this is the same thing as 20 over 1. It's top times top, bottom times bottom. This is an exact answer. Now, when I say show work, you are to show that work on the test. Any answer where you have the right answer, but none of the steps leading up to it, I won't give you credit on a test. So just train yourself to do that. This is called the exact answer. Now, do you see in this problem how it didn't say anything about rounding to a particular decimal? That means stop there. Don't go any further. This is the exact answer. Anything else you give me is only going to be close. Okay, here we go. Next one. Give the intercepted arc. That's just a fancy way of saying give the arc length. Another way of saying give the arc length. Okay, so you always start by writing the formula. It'll help you focus. Even if the formula is super simple, write it down anyway. Okay, now wait a minute. I believe they are not giving us r and theta. Look what it says. Given an intercepted arc. So you see the difference here? It's still the same formula, but this time what have they given you as opposed to the last problem? Yeah, they've given you the S. The arc length is the S, right? So when they talk about intercepted arc, that's really the S value. So they're just giving you something different this time. Same formula, but instead of giving you this and this, they're giving you that. So you got to make sure and put it where it belongs or it'll come out wrong. So I can't go out this way. I'm going to have to continue down here. Let's put the 24 pi here where it belongs. That's this thing right here. Central angle pi over 4. Don't have an r, but I do have a pi over 4 to put right in there. And then let's talk about your math skills. This says r times pi over 4. You want to get rid of this, right? You're trying to solve for r. You want to isolate the r. So whenever you want to get a fraction, rid of the fraction, both the top and the bottom, at the same time, you just multiply by what? Reciprocal. It'll get rid of the top and the bottom at the same time. And then I'm sure all of you know that whatever you do to one side, you have to do to the other side, right? That's the golden rule of solving an equation. So I'm going to knock this pi over 4 out by multiplying by 4 over pi. Likewise over here. Okay, so that'll squash the 4s, squash the pi's, leave me with r. Then over here, 24 pi is the same thing as 24 pi over 1. So you have a pi in the top canceling with a pi in the bottom. So all you have left to do is put in your calculator or do it in your head, whatever you're into. 4 times 24. 96. What's the unit here? They didn't give us one. Okay, questions? Okay, part C. Now they start to drag some decimals in there. So let's see what's going on here. Okay, how long is an arc? I don't have the arc this time. They're asking me for it. If it says given the arc, you put the number in there for the arc. This one says how long is the arc intercepted by a central angle? Okay, there's a few things that have gone wrong here. Number one, this is theta, right? Central, that's the name of it. That's why you got to know the names of these things or else you don't understand what they're giving you. They are giving you theta. So as you get used to things, every time you see the word central angle, maybe you can label that they're giving you theta. Now, remember I said that in these formulas that have theta in them that you're not allowed to use degrees? So we need to go and convert that to radian form, pi form, then we can start the problem. Okay, let's do that. There are 180 degrees in 1 pi. I put degrees down here because I wanted it to cancel with those degrees. So it's 120 over 180 with the pi right there. Now, do you see how the rest of the information is in decimal form? So your best bet, if they have given you anything in decimal form, you can go all decimal. All right, so why don't we get a decimal right here? My theta, because remember, radians is either pi form or decimal form. Those are both called radian form. So I'm going to go all the way to decimal form only because the other number they're giving me is also in decimal form. You can go all decimal. You're never going to be able to work a problem that's in, well, you will, but it'll be harder when it's half fractions and half decimals. Okay, so that's your clue. Let's go in here and go 120 times pi divided by 180. 120 times second function pi, right under the clear button. Divided by 180. I got 2 point. Now, while you're in the middle of a problem, try to hang on to at least 4 or 5 numbers after the decimal, just for accuracy in the final answer. So 2.094. 0.0944. I'm going to go with 0.0944. Hey, everybody with me? All right, now let's go back to the problem. Let's write the formula and get our head focused with what do we have and what do we need to get. So it's arc length is r times theta. How long is the intercepted arc? That means you don't know what this is, so don't plug anything in. So it says r, here's your radius, 11.34. And the theta, we just managed to get it from degrees into radians. Okay, put that in your calculator, 11.34 times 2.0944, and then we can round it to anything that they didn't tell us what to round it to, but I will, and when you don't know what to round it to, you can just ask me. I'm going to round it to the hundredths place. I got 23.75. There's no units here, so I'm just going to give the arc length without a unit.
I have a question.
Yeah.
Before, in like a couple pages ago, we substituted the pi for 180. You could do that anywhere, like anytime. Substitute pi for 180.
Yeah, you can only, substitution is for any two things that are equivalent.
Okay.
So yes.
So the one that we just did, we multiplied 180 by 120, and then we divided 180.
You could do it either way.
So wouldn't it be the same answer?
Hold on, let me look at what you're talking about.
Oh, okay. So you have to do that first, not just.
Yeah, you're not allowed to plug in anything here unless it's in radian form when you're doing these problems, which is why I did that.
Is always going to be degree form, so we have to change it from degree
Yep,
form.
so it's like a double problem.
Okay, gotcha.
Remember what we did on page 2 where we were converting from pi to degrees? It becomes one of those problems as well as an arc length problem. It's a double step problem.
Okay.
Yeah, so now there's one like this on the test. I'm just going to tell you straight out where you will have to come off to the side, convert it to pi form or decimal form, and then go on with the problem. It'll be a 2-step problem. Because that I could tell whether you know how to do 2 different things in one problem. All right, so here we go. Let's go over here. I'm almost done. We're almost out of time. All right, so find the distance between 2 cities, Sioux Falls, South Dakota, and Dallas, Texas. So you have Sioux Falls occurring at 43 degrees along this pole, this equator. So it's 43 degrees is the location and 33 minutes right there. Then Dallas is at, is at 32 degrees and 46 minutes. So you're trying to find the distance between Dallas and Sioux Falls. So this is supposed to go with this. This is supposed to go with this. All right, so you're going to start off like this. To find the distance between here and here, first you're going to go,
We can't see.
43 degrees and 33 minutes. Yeah, let me know whenever that happens. You're going to subtract off the other one, which is 32 degrees and 46 minutes. Go ahead and put that in your calculator. Okay, I'll review with you how to grab those symbols. Okay, first one is 4333, and it's not all in degrees, so 43, second angle, paste that degree symbol, 33, second angle again, go grab the minute symbol. There's the first one. Now minus off the 3246. 32. Put the degree symbol on it. Grab the 46. Okay, so now you're at. Now when you see that there's no more degrees and minute symbol, there's no symbols at all, that means it's all in degrees. So now you are at 10.7833 degrees. And it's easier when it's just in one unit rather than a mixture. Okay, then it says use the arc length formula. Remember to convert into radians. All right, so if this is in degrees right now and we want to go to full radians, we have to go like this. 10, this is a mixture of a few problems. 10.7833 degrees. Okay, here we go. We're going to convert. We're going to get rid of the degrees. The one you want to get rid of has to be on two different levels. There's 180 degrees in pi radians. Degrees are gone. Now we're going to go 10.78 times pi, 10.7833 divided by 180, and then you won't be in degrees anymore. Now you'll be in radians so that you can use the arc length formula. Okay, so put that in your calculator now. So this is 10.7833 times second function pi divided by 180, and you have 0.1882. Okay, and you're in radians now. When you're in radians, you don't need to put any unit. There's no unit. Radians just means decimal. Okay, now use the arc length formula. So it's arc length is equal to radius. I don't believe I gave you the radius of the Earth, so I was supposed to, though. This is the theta. So the radius for the Earth, I think I have it written down somewhere. Is approximately 6,400 meters. Write that here. Radius of the Earth is approximately 6,400 meters. Okay, now come here, and the radius is 0.18. Whoops, nope, didn't mean to do that. 6,400 meters. Excuse me?
Is that supposed to be kilometers or meters? It sounds really small.
Let me see what I have here.
That's like, what, like?
Yeah, I think it's in kilometers. Well, I don't know. I'll have to check it out.
Does the unit matter?
Yeah, it matters. I mean, not with the calculations. I think it's, I don't know, I'll have to check it out, but just so we can get the problem done. 64 kilometers, and then put in the theta, which is 0.1882. That's your theta. Multiply it out. 6400 times 0.1882. And you get 1,204.48. And put the unit on that I gave you. Okay, that's all I have time to do for today. It was wonderful meeting you. I will do the rest of them on the video so that the video will include all of them. Okay? Let me turn this off. Email me if you have any questions.